Okay, so today we're doing part 2 of linear programming. We're going to go over one problem that's at the end of your notes here. And I'm going to have you guys do a little bit of independent thinking today because I want you to try to figure out some of these things as we go. First of all, let's read this together. It says, bottled water and medical supplies are to be shipped to victims of an earthquake by plane. Each container of bottled water will serve 10 people. That's probably an important fact that you need to know. And each medical kit will aid 6 people. That is also an important fact that you need to know. All right. If X represents the number of bottled waters to be shipped and Y represents the number of medical kits, write the objective function that describes the number of people who can be helped. So I'm going to give you a moment. I want you to write this down in your notes and we'll check in just a second, okay? Okay, so your objective function should be Z equals 10X plus 6Y. So hopefully that's what you got. Okay? The next line says each plane can carry no more than 80,000 pounds. That's an important fact. The bottled water weighs 20 pounds per container, and each medical kit weighs 10 pounds. So now I want you to write a constraint for this. Okay, so this constraint, 20 per container of water, plus 10 per container of the medical kits, those added up have to be less than or equal to 80,000 pounds. Okay, so that's one constraint. Now, the next one says, each plane can carry a total volume of supplies that does not exceed 6,000 cubic feet. Each water bottle is 1 cubic foot, and each medical kit also is 1 cubic foot. Yep. So this one, you're going to write 1x plus 1y is less than or equal to 6,000. Okay, so these are our constraints that we found above. What we want to do now is graph these constraints. Okay, so first of all, I'm going to look at this first constraint right here. Where are my x-intercepts for that first one? If I cover up my x, what's my y going to be? 6,000. And if I cover up my y, what's my x going to be? 6,000. So I'm going to make my scale by thousands, but I'm just only going to say 1, 2, 3, 4, 5, 6, and so on. Okay? So if I'm doing this in thousands and I said my y value is at 6,000, that's my first point, and my x value is at 6,000, I need to make a line for that point. I'm just going to connect my dots. So my first line has been written. We want to do the same thing with the second one. So if I cancel out my x's, my y's would be 8,000, right? So I come up to the 8 and put a point. If I cancel out my y's, what's my x going to be? What's 80,000 divided by 20? 4,000, okay? So that would be, 1,000. That would be right here. I'm going to connect my point from the 8,000 on the y-axis to 4,000 on the x-axis. Okay. So, we have a couple things we got to do yet. We need to shade our feasible region. First of all, we need to find what is the feasible region for the first line, this one. Okay? So, I'm going to find a pen again. If I put in 0, 0, this point right here, for this first region, if I put 0 in for x plus 0 for y, is that less than 6,000? Yes. So, for that triangle, I'm going to shade all of this.
Why not just the,
Because 0, 0 works. Okay? So, I'm going to do the same thing for the second line. I'm going to change my colors. Okay? It is, yep. So if I use 0 in for x, 20 times 0 is 0.
Is there ever a time where it's above?
Yes, there is, but not this time.
It has to be negative or...
It works sometimes. It depends on what your constraint is. If this said greater than or equal to 8,000, then it would have been the other, okay? So now I'm going to shade this area. Yep. So my common area of shading, my common area of shading, if I shaded it solid now, is this. Can you guys see where that is? Okay? That's my common area. So, what we need to do now is find all of our corner points. This corner point is what? 0, 0. That one's easy. How about this corner point? It's actually 0,6,000. Because remember, we're doing it in thousands. Okay? How about this point? 4,000, 0. Right? And we still need to find this point right here. So don't base it on the graph. Base it on finding the solution with these two equations. Okay? So we need to eliminate either the x's or the y's. So what am I going to multiply the top by to eliminate one of them? You can do that, negative 20, okay? Multiply the top one by negative 20. So I'm going to put that over here, negative 20x minus 20y, and I'm just going to use equal signs because it doesn't matter right now when we're trying to find a common point, is 20 times 6 is 12,000, right? Oh, no, is that more than that? Yeah, it's one more. 120,000, and it should be positive or negative? Negative, okay? Then I'm going to put this other one underneath it. Okay? My x's cancel. So I have negative 10y is equal to 40,000. So what's y going to be? 4,000. So my y value for this point is at 4,000. Okay, it's an ugly 4. Now I've got to substitute that back in for x. I'm going to use this equation right here. So if I put in 4,000, I have x plus 4,000 is less than 6,000. What's my x going to be? 2,000. Yeah. Okay? All right, so the next step to this, you guys, is what? Which one is the greatest in our profit function, our objective? Okay? So here's our objective function right here. And I need to plug in each of those points for this. So bear with me. I'm going to erase one little part over here so I can have room to test it. It's 10x plus 6y. I'm going to erase a section here so I can test the objective function. Okay, so my objective function was z equals 10x plus 6y, right? So I need to test each of these points, there's 4 of them, to find out which one's maximum. Okay, so if I put in 0, 0, what is that one already? 0. I'm not even going to bother testing that one. That one's pretty easy. 0, 6,000. 10 times 0 plus 6 times 6,000. Yep. That's that one. Now let's test this one. 10 times 2,000 plus 6 times 4,000. 44,000. And then the last one, we have, it was supposed to be 4,000. So 10 times 4,000 plus 0. So that's 40,000. Yep. So which one is our maximum? Yep. It's this one right here. Or this point right here. So we need to send 2,000 bottles of water and 4,000 medical kits, right?